Each CPU cycle of a 64-bit processor processes 64 bits of data. Bits are queued up in the RAM and await processing and are cycled through in chunks. Since most data is one- or two-dimensional, the bit organization works great. However, this limits everything to binary bottlenecks. The most common solution is batching and organization. However, that too has its mathematical limitations. While effective for low 2D system logic, it lacks the required structure and standards for effective data processing. Our proposed solution is encapsulating the data in SHD-CCP packets, which are neural-symbolic placeholders for higher dimensional data, allowing extrapolation of multidimensional data without hitting the theoretical limitations of vector embeddings. Traditional data is flat, like a single frame of a movie. By sending calibrated packages of known parameters sequentially, we can create 3D structures with this 2D process. An AI can now perceive the entire story, not just the current state. It will know how a system evolved, and be able to recognize cause and effect relationships through chains of reasoning and grasp narrative behind the data. The structure is more than just data, it's physical representation of a process. Each layer can be a step in an agent's reasoning, creating a buffer of thoughts that is both memory and a logical map. So why would we do this? Modern AIs use data from humans, which traditionally has been in the form of 2D arrays. We can manipulate these arrays into 3D objects, but that is the highest dimension we can add to these arrays. Mapping concepts to points in a vast meaning space, we use vectors or tensors in a lattice structure. AI systems can see similarities in the data structures when they are arranged like this. Google DeepMind new research published a statement: for any fixed embedding dimension, there will always exist retrieval tasks that simply cannot be solved, no matter how much data you throw at them or how long you train. This is actually a mathematical problem, and not something more hardware can solve. When you input data into an AI system, it creates a one-dimension object called a vector in point space. We add another vector, we are able to create a tensor matrix using both dimensions. This allows us to see relations in the data. Adding more creates a 3D object. AI systems analyze these objects for patterns. As you add more dimensions to data, the space expands exponentially, causing all of the data points to become sparse and isolated from one another. This makes the concept of distance or closeness lose its meaning, rendering tasks like finding the nearest neighbor almost impossible. Each line on the graph represents a different order of complexity, commonly expressed using Big O notation. As data increases, the time steps required to solve increases in difficulty. No amount of training can overcome this mathematical wall. Eventually, the system chokes on complex queries. The SHD-CCP Protocol solves this by changing the paradigm. Instead of trying to represent everything geometrically in 3D space, it uses a compact, 64-bit packet that acts as a compressed, neural-symbolic hardware-native command for the GPU. This structure compresses many different hyperbolic states into the optimal packet size for CPU and GPU processing. Choosing an O1, constant time algorithm for data structures has predictable and incredibly efficient advantages. In high-performance computing, O1 signifies an operation whose execution time is independent of input size, completing in a predictable number of clock cycles. The AI industry is built on a paradox. Trillion-dollar models are bottlenecked by $100 parsing inefficiencies. Every major tech company is hemorrhaging money on underutilized hardware and wasted energy because their data ingestion pipelines follow O(n) complexity. We hold the patent for the architectural shift that solves this problem, moving the industry to O1, constant time data access. Our core asset is the first mover, foundational patent covering O1 data compression and streaming. This is not a patent on a single application, but on the fundamental mechanism that every major technology company will need to adopt to remain competitive in the next decade of AI. This creates a powerful, defensible licensing opportunity and positions the company as a key enabler of the future of computation, making it an acquisition target for every major player in the cloud and AI space.